Why does a person buy an expensive item they cannot afford just because they had a bad day? While humans often act based on feelings rather than logic, current AI struggles to predict this irrational behavior. The paper Large Emotional World Model explores how to fix this by teaching machines to understand the emotional drivers behind our actions. Existing world models, like Sora, are excellent at simulating physical regularities, such as gravity or object permanence. However, they fail to account for the emotional states that act as hidden variables driving human decisions. This research builds on the theory of mind, the idea that we predict others' actions by estimating their internal state. The authors leverage recent findings that large language models already contain specific neurons responsible for recognizing emotions, suggesting that affect is a systematic modulator of cognition. To bridge the gap between physical simulation and human behavior, the researchers introduced the Large Emotional World Model, or LEWM. This framework jointly represents visual observations and emotional states to better predict how the world evolves. To train this model, they constructed the Emotion Why-How dataset using multimodal clips from movies and TV. This data maps the why, the emotional cause of an action, directly to the how, the way that emotion alters the future state of the world. The core methodology relies on dual pathway reasoning. While standard models only track the observable path from state to action, LEWM adds an implicit channel that routes the state through an emotion first, before determining the resulting action. Let's examine the specific implementation mechanisms that allow the model to process these dual pathways effectively. The researchers implement a coupled transition factorization that prioritizes emotion. Crucially, the model predicts the next emotional state first, and then uses that emotion to condition its prediction of the next environmental state. Here is the architectural overview of the system. You can see how the multimodal memory encoder feeds into distinct but connected world and emotion models, ensuring that latent emotional embeddings directly influence the generation of future frames. When validating the model, the authors found that filtering out the emotional module caused an 8% drop in accuracy on subjective tasks. Surprisingly, even objective reasoning tasks suffered a small performance hit, proving that emotion is useful even for logical consistency. This work represents a shift from building physical simulators to social simulators. For applications like autonomous driving, understanding that a pedestrian is angry or distracted is just as important as knowing their walking speed. To learn more, head to emergentmind.com.